Hey class, I am going to go over this quiz so you can see how to do everything. So I know we reviewed in class, but I thought you might have some other questions. So here we go. So let's try to sketch this graph. Well, what do we know? We know A, H, and K. So A is -1, H is +5, and K is -3. We've learned that we need to graph these asymptotes. So if this has a horizontal shift of 5, I'm going to have an asymptote at, let me grab this, at +5, wherever H is. Okay, I'm also going to have a horizontal asymptote at -3. So I'm going to come down here and at -3, I'm going to have a horizontal asymptote. Since A is -1, I'm going to count from my center point just like I would a slope, down 1 over 1. And then I would go in the opposite direction to get the other branch. And right here, I have a little sketch. I know that my rational function, my parent function, has a branch on the opposite sides of the asymptotes. And there's my graph. Now, part of question 1 is to state the y-intercept. Well, to find the y-intercept, I plug in 0 for x. So if I plug in 0 right here, I'm going to get -1 over -5 minus 3. So I have a positive, let's move down here, 1/5 minus 3. You can get a common denominator of 5. So that's 1/5 minus 15/5. And that gives me -14/5. So my ordered pair would be, remember we said x was 0, so y is -14/5. A few people on the quiz wrote it as 2 and 4/5. Some people put it as, I'm sorry, -2 and 4/5 or -2.8, and that was fine. Okay, so now let's look at the second one. Now the second one's a little bit trickier because we have a common factor. So let's take out a 3, and then we're left with x plus 4 in the denominator. And we have a 6 in the numerator. But notice those actually reduce. So I can take out a 3, and then my a on top becomes +2. Okay, plus 1. So let's define our a, h, and k in this equation. So a, I just reduced that to +2. H is going to be -4. It's what makes the denominator 0, which is -4. And K is +1. And again, let's throw in our asymptotes. So we have a vertical asymptote at the horizontal shift, which was right here at -4. We have a horizontal asymptote at +1. So we have, vertical at -4, horizontal at +1. Now, A is +4, or +2. So from the new center point, just like a slope, I would rise to run 1. So this point right here is on the graph. And then I'm going to do the same thing in the opposite direction, down and over, and there are my branches. And that's how I graph this rational equation. Now, we're asked to find the x-intercept. Well, that means 0 is y. So I'm going to put a 0 in right here. So that's going to give me 0 equals 2 over x plus 4 minus plus 1. So I'm going to subtract 1, right? So let's subtract 1 from both sides, and we're left with the rational expression 1, and I'm going to write it over 1 equals 2 over x minus 4. Now at this point you guys should know what to do. We just cross multiply. So we get a +2 equals -x minus 4. -x minus 4, because we have to distribute that -1 in, right? It's -1 gets distributed in. So add 4. Add 4, and that gives us 6 equals -x. So x is -6. So that's the x coordinate. But what did we plug 0 in for? Y. Therefore, we have to write an intercept as an ordered pair where x is -6 and we plugged in 0 for y. So there are the first two problems. Now let's go down and look at these rational equations and how they would graph. Okay, again, to find an x-intercept, we plug in 0 for y. So we plug in 0 for y, and when you do a cross product, what's going to happen when you plug in 0 right here is the denominator becomes 0. So really it's just going to be 0 equals x squared, 2x squared minus 6x. So we just have to find these zeros. So let's factor out a 2x, and we get x minus 3. So our zeros are 0, right? This is the 0, that's 0, because we always set them equal to 0 by the zero product property. So 0 is my x coordinate. And my other one, x minus 3 equals 0. That's got to be positive 3. So those are my two x-intercepts. Well, if it's crossing the x-axis, we know the y-coordinate has to be 0. Because think about it. If you're on the x-axis, you're going to go 0, 0, and then 1, 2, 3, up and down 0. You're not going to go anywhere up for the y in the y direction, so it's 0. Okay, to find the y-intercept, what do we plug 0 in for? X. So let's plug 0 in for x. We've already done that, haven't we? That's what we did here. We have 0, 0, so the origin is both an x-intercept and a y-intercept. Okay, let's look for a hole. Holes occur if we have factors that cancel. So let's look at this in factored form. We have a 2x times x minus 3 on top and an x plus 4 on the bottom. Do we have any factors that cancel? Nothing. So this does not have a hole, so it's none. Now, vertical asymptote. That is an up and down line, a line that goes straight up and down. We write it as x equals some value. Well, what makes the denominator 0? -4. That is our undefined term. That's where we're going to have an asymptote going up and down. Horizontal asymptote. Okay, we learned some rules for horizontal asymptote. One's a Kim, one's a dolly, and one's an even. This one is a dolly because the top is bigger. So let's do some long division. Okay, or in this case, we can use synthetic. So in my box, I can put -4, and then I have a 2 and a -6 as my other terms to pull out of here. We've learned synthetic division. We pull -4 here, 2 and -6, right? And then synthetic, bring down the 2, multiply, -8, add, -14, and we know how to throw the variables in. This is x, 2x minus 14 is equal to y. Now, a lot of people forgot to put the equals y. Slant asymptote, y equals 2x minus 14. And when we have a slant asymptote, we have no horizontal asymptote. And then our domain, okay? Our domain is going to be all real numbers except where the denominator is 0. So where the denominator is 0, that excluded value is from -infinity to -4. And then it picks up on the other side of -4. It's just an asymptote is like a river. You just have to hop the river and get to the other side. So that one's domain is -infinity, -4, -4 to infinity. Do the same thing for this equation. X-intercepts, plug in 0 for y. That crosses out the bottom because if you cross multiply, it becomes 0. So we just need to factor the top, and we have x plus 6, x minus 5. Now at this point, it looks like we have two x-intercepts. It looks like we have one at -6 and 0, and +5 and 0, but we're going to figure something out in just a second, so we'll come revisit these intercepts, okay? Now, to find the y-intercept, we plug in 0 for x. We plug in 0 for x, that disappears, this disappears, And this disappears because 0 times all these things are just 0. So what are we left with? Negative 30 over negative 50, which simplifies to a positive 3/5. So this is going to be x is 0 and y is 3/5. So that's our y-intercept. Now, let's look at some holes. How do we get holes? We get holes from factors canceling. So let's look at our polynomial, or our expression up here, this rational expression. We're going to look at it factored. Okay, I've got a factor at the bottom. I can take a 2 out. And when I take a 2 out, I'm left with x squared minus 25. Well, we know that's the difference of 2 squares. So let's factor that into x minus 5 times x plus 5. Okay, what do we see here? We have a hole because those two factors, x minus 5's, they cancel out. So this 5 right here is actually not an intercept. It's a hole. So let's go down here and put 5 as our hole. Okay? Now, if we do that, we need to find the y-coordinate. Well, what we want to do is take what's left after we've simplified the polynomial, which on top we have an x plus 6 because the x minus 5 canceled. And on bottom, we have 2 times x plus 5. Now, all you have to do is plug a 5 in for x. So if I plug a 5 in here, I'm going to get 11 on top. And if I plug a 5 into the bottom, that's going to be 5 plus 5 is 10. And 10 times 2 is 20. So there we go. It's 5. And then the y-coordinate is 11/20. That's how we find the hole. Now, a vertical asymptote. We're going to go back to the denominator. What makes the reduced polynomial 0, where x is negative 5. And then a horizontal asymptote, we need to look at the ratios. Okay, or look at we need to compare the coefficients and the exponents. Okay, we have an x squared and we have an x squared. These are both even powers. Whenever they're even powers, we take the ratio of the coefficients. That's 1 on top, 2 on the bottom. So that's just a half. So the horizontal asymptote is y equals 1/2. And the very last, slant asymptote. Well, if we have a horizontal, we do not have a slant. It's either one or the other, right? You can't have both. And then our domain. Okay, our domain is where the x's don't exist in the graph. Well, when we factored this, we had an asymptote at negative 5 over here. That's my asymptote. And then I had a hole at positive 5. So that means the domain is undefined on both negative 5 and positive 5. So we have to take those out of the domain. So I've got to write this from smallest to largest, so negative infinity up to negative 5. Then it jumps over negative 5 because that's the asymptote. Then I'm going to pick up on the other side of negative 5, and I'm going to go up to my hole at positive 5. And then it jumps over the hole, and then I'm going to pick up on the other side of the hole, and I'm going to go to positive infinity. So right there we have our domain. Now let's go to the second page. It says state the coordinates of the hole. Okay, we probably wouldn't give this to you unless it did have a hole. So guess what? This one has a hole. So what we have to do is we have to factor the numerator and the denominator and see which factor cancels. Well, hopefully you recognize the cube. I think most of you did. And it's going to factor into x plus 2 times x squared minus 2x, because remember, same, opposite, always positive signs, plus 4, all over x plus 4, x plus 2, because it's the difference of squares, and x minus 2. Because if you FOIL it out, multiply that out, that's x squared minus 4. Now, our factor that cancels is x plus 2. But we know x plus 2, if we set that equal to 0, our 0 is negative 2. So that is the x coordinate. And for the most part, everybody got that value. But we're still having trouble finding the y value. How do you find it? You take the negative 2 and you plug it into the reduced polynomial in all places you see an x. So we're going to plug it in 1, 2, 3 places. So let's plug it in. So I'm going to go down here and I'm going to plug in negative 2 and I'm going to square it. Minus 2 times negative 2 plus 4. That's the top or the numerator. And in the denominator, I'm going to have negative 2 minus 2. So in the denominator, I have a negative 4. In the numerator, I'm going to have a 4, because negative 2 squared is 4. Negative 2 times negative 2 is another positive 4. And then back here, I have a plus 4. So 4 plus 4 plus 4 is 12. So 12 divided by negative 4 is negative 3, and that gives me my y coordinate. So there's my hole. Okay? Now, got a little mess here, so let's clean it up so we can see the next problem. Okay, so that answer, I'm going to rewrite it so we have it up here. And the answer was negative 2, negative 3. Okay, next problem. Identify the transformation, okay? So we have to look and figure out what's happening. I need to factor the numerator out, or the denominator out. So let's take a 2 out, and we're going to get x plus 4. Okay? Well, when I factor that out, I can see I have a positive 4, so that means the left is always the opposite. It's the left shift of 4. But then what about this 2 and this 1? That gives me my factor, my a factor. Well, that means a is a half. Well, anytime a is less than 1, it's shrinking. So I can go over here and say, well, it doesn't stretch, it doesn't stretch. It's either this shrink or this shrink. It's shrinking by a factor of a half, so both of those are right. So I just need to decide on left, right. Well, this one's a left 4. So the answer is D. Okay, now let's get to solving. Okay, solving these. What I'm going to do on this first one is I'm just going to make this whole number into a fraction and do cross products. So 3 times 1 is 3, and 1 minus x squared times negative 1 will change the signs. So then it's going to end up being x squared minus 1. Okay, so that time I change my signs and I switch the order, right? So if I multiply negative x squared by negative 1, that's positive x squared. And if I multiply positive 1 by negative 1, it's negative 1. Okay, to solve this, I'm going to add 1 to both sides. So I'm going to get a 4 over here is equal to x squared. Well, what two values are true? We've talked about this multiple times. X has to be both positive and negative 2. Now, the only catch is on rationals, you need to go down here and make sure that 2 or negative 2 doesn't make your denominator 0. Well, the only thing that makes my denominator 0 is 1 and negative 1. So these two answers of positive and negative 2 are both good answers. They're not extraneous. Okay, second problem. Before we start, we have to factor these so we can see what our denominator is. So this is going to be an x plus 1 times an x minus 1. And the same thing with this one over here. This denominator is x plus 1 times x minus 1. So first thing you want to do is factor the denominators. So our common denominator is an x plus 1, right? Whoa, I'm getting a little crazy here with my writing, and x minus 1. Now, this first fraction, it's missing one of the factors. It's missing an x plus 1. So we need to multiply the top and the bottom by x plus 1. And that gives us x squared plus x once we distribute, right? X times x is x squared. X times 1 is x. Now, the second term has both factors. So all I have to do is bring down the numerator of x squared minus 5. And then the final, it's equal to this polynomial, Well, this has a full denominator also, so I don't need to multiply this numerator by anything. It's just going to come down as x squared plus 7x minus or plus 2. Well, once you get one common denominator, you can ignore the denominator. I'm sorry, numerator under one denominator. We can ignore the denominator other than thinking in our head, x cannot be positive or negative 1, because that's what makes the terms in the denominator 0. So if we get one of those answers, we're going to have to throw it out. Okay, so now let's solve this. So let's combine our like terms, and I have 2x squared plus x minus 5 is equal to x squared plus 7x plus 2. Now let's get everything to the same side because we have a quadratic, so we have to get it equal to 0. So x squared, subtract 7, right, I just subtracted that x squared, by the way. Okay, and then subtract 7, and that gives me negative 6x. And then I'm going to subtract 2, and that gives me negative 7 equals 0. Now, that will factor. What multiplies to 7 has a difference of 6, and it's x minus 7, x plus 1. So our two zeros, using the zero product property, are positive 7. So x is 7. And then x is, this one gives us negative 1. Well, what did we originally say? X cannot be either positive or negative 1. So we actually have to throw that solution out. We only have one answer, 7. So x equals 7 is the one and only solution. Okay, next one up. We have to factor this denominator to x times x plus 2. Well, that makes it kind of nice because I already have both of those factors in the problem. Here's my x. Here's my x plus 2. So I need to multiply the first one by an x plus 2 because that's my missing factor. I need to multiply the second one just by x. And the third term has the whole denominator, both x and x plus 2. So the first one I'm going to have to FOIL. And I'm going to get x squared minus x minus 6 plus 3x from the second term plus 6 from the third one equals 0. Now let's combine everything, and I've got an x squared. Negative x plus 3x is plus 2x. Negative 6, positive 6 is 0. So I'm going to end up with x times x plus 2 equals 0. Well, using the zero product property, x is 0 and x is negative 2. Okay, so those are our solutions, but we need to go back and check and look and see what makes our denominator 0. Well, x equals 0 will make this denominator 0, so x cannot be 0. This one, x plus 2, if you set it equal to 0, our eliminated solution would be negative 2. Well, those are the two answers we just got. So guess what? We can't use any of them. And this one has no solution. All that work for no solution. But that one has no solution. Okay, so let's do this last one. This one has an x plus 2, an x, and a 5x. So all those are part of our denominator. So we're going to have 5, an x, and an x plus 2. So our first fraction is missing, a 5x. So we're going to have a 15x in the front minus the second one. Well, it's missing both the 5 and the x plus 2. So I've got to multiply negative 1 by 5x plus 2. Okay, now I need to be real careful here because when I go to distribute this negative 1 in, it's going to end up being negative 5x minus 10. And then equals, and then all the way across, I have a positive 1 here. And what am I missing? I have the 5, I have an x, I just need an x plus 2. So let's multiply this by x plus 2. So all this is just going to equal x plus 2. Once you get a common denominator, you can ignore the once you multiply through, you don't need the common denominator other than to say, well, if I get 0, it's a bad answer because of this and this. And then what can x not be in that one? X can also be -2. So if I get either one of those answers, I've got to throw them out. Hopefully we won't get one of those this time. Okay, so let's combine, and we get 10x minus 10 equals x plus 2. And then let's combine like terms. Let's bring the x's over, so that gives us 9x. And bring the positive 10 over. Let's bring that 10 to the 2. Get our constants on the other side, so 12. So x equals 12/9. Well, guess what? We can reduce that by 3. So that's going to be 4/3. Now, was 4/3 one of our extraneous solutions? No. So 4/3 is the one and only answer we have. Okay, and that is the end of the non-calculator part. So I'm going to stop there, and we'll look at the calculator part in a minute.